Hi, everybody. Can you hear me okay? All right. First of all, if everybody would just try to look at the bottom left-hand side of their screen and the microphone.
Hit the mute. Hit mute.
Thank you. So, good afternoon, everybody, and welcome to Streaming with Steve. This is our second installment of the iKids virtual classroom workshop that we are in partnership with the Tesla Science Center and the Spur and Long Island STEAM, and we're so glad to have you here with us today. We have a very fun and exciting workshop for us to have some edutainment, so to speak, after our hard work during the AM hours, taking care of some assignments from your teachers online, and hopefully you had a nice lunch break. And now we'll have a little bit more fun continuing our education and specifically working in the area of STEAM or STREAM, science, technology, engineering, and math.
Yeah.
So, again, welcome. My name is Steve, and you know, everybody can assume the big reason that we're here today is because of the COVID-19 pandemic that we're all experiencing and the recent push to establish some virtual interactive online learning. So that's our main purpose here, and we're so happy to connect with you guys today. So moving into the class, I just want to establish some ground rules that would really help us work much better together today. And number one, we already went over. If you could please mute your microphone on the bottom left-hand side of your screen. And the way we'll work it is when you participate with us, I will either see your hand in the air and call you by name, or you can write your name down on a card or a piece of paper like this and hold it up so that I can read your name and call you out. If I call your name, simply move down to the microphone icon and unmute, and you can share with the rest of us, and that would be great. So, with that said, what can we expect today? So this is the plan for today. We're going to talk about the supplies you need and the topic, and then we're going to have pretty much 4 sessions of 15 minutes each, and those are going to be broken up as follows. We'll have 5 minutes where I discuss the challenge and the engineering problem that I want you all to solve, and I will give you some demonstration on how to do that. Okay, and then that will be followed by 5 minutes of your own time where you get to try and meet that challenge, try to solve the problem on your own, and you know, see what we come up with. Following that, we'll have a third 5 minutes where we all come back together with our results, and we'll get to share them with each other and talk about what went wrong, what went right, how we might be able to improve them. And that will happen 4 times. And in between, after 2 sessions and before the last 2, we're going to have a health and wellness break for about 10 minutes that you can all partake in. I strongly recommend it. We have Mary back with us today, who was excellent in our first workshop last Friday. And she'll be going over some stretches and yoga movements with us all. It's very refreshing and a great way to refocus. So following that, we will have a wrap up, quick discussion, and a further lead into this Friday, where we're going to hold our next workshop that I hope you all can join us for. So let's get going. Today we're going to talk about rockets. Okay, rocket science is such a fun topic for us As far as steam is concerned, it's a great way for us to engineer, design, and create our own cool things that totally use math, science, technology, art. And if you want to throw the R into stream, so much research can be done to learn about them and to find out what the world is doing with them and so forth. So let's start. I want to talk to you about our supplies for today, which are very basic, considering that people might not have the resources on such quick notice after being sent home from school. So we're trying to do our best with feasible materials for now. So for today, all you really need is some paper. It can be printer paper. It can be construction paper. It would be great if you had a scissor, some tape. It can be any type of tape. I have some masking tape here. I have some clear Scotch tape here. And I have some duct tape or Gorilla tape as well. It would be extra helpful or enjoyable if you had some other items, but they're not completely necessary. Balloons would be great. A water bottle would be excellent to have, an empty water bottle, and some markers, pens, pencils, whatever may be that you have. I think arts and crafts, and we'll get along just fine, and you'll be able to create your own unique product, okay? And I want you guys to keep that in mind while we're working together today. There are no wrong or right answers, okay? What you come up with in your imagination and you use your creativity is going to be your very own invention, which is the best part about this. And then we're going to share them with each other. So I hope everybody has followed along fine thus far. I'm going to ask my production assistant, Doug, because I am right now, okay, never mind. I was having trouble viewing all of our participants today, but now I have that, so I apologize about that. So let's get into some basics as far as what you'll need to be doing today. Okay, so how are we going to build rockets out of paper? Well, I have a couple examples here, and these are rudimentary, no parts to the rocket yet, okay? And the idea is that I have a tube in here that I have sealed off, okay, on this outer tube, and an inside tube. So basically, we're gonna do the first 5 minutes on a very basic rocket that we can blow into one tube and shoot off the rocket out of another. So if you watch me, this is basically how it works. Okay, so I don't know if you saw that, but the outer tube shot across my room. I'm gonna go grab that. In the meantime, you guys grab 2 pieces of paper, and we're gonna start off with basics, and then I'll let you have your 5 minutes to follow along. So 1 second. Okay, I'm back. So I'm going to take a piece of paper and I'm going to roll it up. I'm going to use a pencil just to give me a nice, and you guys don't have to do this yet, just follow along. I'm going to give myself a nice, pretty skinny tube. And once I have it here, I'm going to grab a piece of tape. And while I'm doing this, I'll talk a little bit about the history of rockets. Back in the year 1232, thousands of years ago, was when the first documented use of rockets is recorded. And that was by the Chinese. They were at war with the Mongols, and they figured out a way to get their arrows to propel with an explosion much faster than they could shoot their arrows otherwise. Since then, over thousands of years have passed, and now, as you know, we are visiting the planet Mars with our rockets today. So the implications of how they have changed our human history are huge. Like I said, for me, they're just fun to play with science and math. So basically, when I leave you, I want you to make one tube, okay, using tape and paper. If you want to cut it, you can, but you don't have to. All right, and then what you want to do is you're going to have a second tube that I'm going to leave it to you guys. You need to figure out how to not only roll the second piece, but now you're going to try and roll it so that it's wider than the first piece, okay? Also, if you notice, the piece that I have, the wider piece, is shorter than the first piece, okay? The reason I did that is because when I place it over the launch pad piece, the launch tube, it's shorter, so I have room to exhale the air pressure out of my lungs into the tube and shoot off the rocket, okay? Don't worry about how the rocket looks for now. The second step, we're going to talk about making it look more like a rocket with some particular parts that most rockets have. When you make these, when I let you go very shortly, make sure the big tube, the outer tube, you're going to need to seal it off on the top so that when you blow into the inner tube, no air can escape the rocket piece, okay? Also, along the seams of the tubes that you make, you want to make sure that you have tape going all the way up because you don't want any air to escape, okay? So with that said, I'm going to leave you for making two tubes, one shorter than the other, one skinnier than the other. Seal off the top of the wide tube, and we'll come back in 5 minutes and see what everybody has. All right, everybody. So have fun, enjoy some music, and we're going to try and get a 5-minute timer up there for you. Doug, Ivy's mom says she cannot log in. I just forwarded you her email. Hi, Ava, I see that you have your hand up. If you'd like, you can unmute your microphone and go ahead and speak. Ava, the microphone would be on your bottom left-hand side of your screen. Right now, we cannot hear you, so you would have to unmute if you want. Thank you. Okay, Doug, if you can hear me, the students are telling me that they need our permission to unmute their microphones.
Okay, so I built mine, and this is me testing it.
Okay, Ava.
It worked better earlier.
Thank you, Ava. Can you please just wait until we all come back and share? Thank you. Excellent. Okay, everybody, why don't we take another 30 seconds to finish up this first step, and we'll start with Ava, because it sounds like she's ready to show us how her idea works, and I can't wait to see what everybody else has as well. Okay, so let's go ahead and stop what we're doing and get ready to share with everybody. So like I said, I will unmute Ava. Hi, Ava, how are you? How did you make out?
I did good. So what I did to get my small tube is I used a pencil.
Okay.
And first I taped the two sides, and then I did the long strip.
Excellent.
that was what I did. And then over here, what I did is I did one this way, one diagonal, and one diagonal.
That's great. That's what I ended up doing too. Okay,
And
good.
then I also put tape on the bottom of here so my mouth doesn't get the thing moist and then it starts to like break.
Now that is an excellent idea. You took care of the technology knowing that, oh, that looked excellent. So just to finish that thought, the fact that you thought of the paper getting moist from your mouth and you solved that problem, that was wonderful engineering. I'm impressed. I hope everybody does that. So, okay, Ava, please mute again. I see you did already. And if we could have another one of our participants raise their hand or a card that you might have written your name on. Okay, I see. Is it Diana? Is it Lola? Okay, Lola, unmute. And I think you should be coming up. Here you are. How are you, Lola?
Good.
So what's going on over there?
Well, I used a pencil also to roll this up. And then for this one, I used big tape like this so it would cover the whole thing here.
Okay.
Not that small.
It's okay, I got this one fine.
It went.
You want me to-
Well, it works, but
Okay, excellent. So what about, sometimes I love talking about problems when we engineer. What problem, if any, did you run into that you were able to figure out or get over? Or was this just easy? Lola, I apologize, but you have been muted that whole time you were describing. Mr. Doug, if you could please help us with the muting unmuting issue, that would be great. Hi, Lola. I'm so sorry. Can you briefly go over the problem and how you solved it?
on the big tube at the top when I put the tape on it,
Yeah.
when I put this in, it was sticking to the top because the tape was sticky underneath.
Oh, yeah.
So I had to get another layer of tape and put it facing that way so it wasn't sticky anymore. So it could go in and it wouldn't stick to it.
Cool. So instead of double-sided sticky tape, you made double-sided not sticky tape. Excellent. Thank you so much. All right, let's talk to one more person and we will move on to challenge number 2. Oh, and I see my friend from Friday, Alexi. Alexi, can you try to unmute? I'm going to try and help you. Excellent. I think you have it. How are you today?
I'm good.
It's good to see you. So what happened with your experience?
Well, what happened is that so I realized how you can stick the top bit. I realized how you can do it. So what I did is I sticked it round, so a piece of sticky tape round it, and then I put the rest of the sticky tape on top of it together.
Very good.
Did another fold over it.
Very good.
And it works.
Let's see. Excellent, Alexi. It looks like you're having fun with it, huh?
Yeah.
Okay, cool. Alexi, do you know about any of the forces at work right now that we're playing with? Or laws of motion, maybe?
Yeah. Actually, I do. Well, when I blow, it makes I don't know how to. So it actually does air resistance. So there's something pulling on it.
Yes.
Propulsion is making it go forwards, but
Right.
it's having air resistance as well.
Yes, well, there's air resistance definitely in play, and we're going to address that in step 2. But your propulsion is a result of Newton's third law of motion in action. So when you blow and exhale into the tube, you're creating air pressure that pushes up against the outside tube. And Newton's third law states that every action has an equal and opposite reaction. So while your air is pushing up on the rocket is pushing down against the direction you're working in. So both actions acting against each other separate the rocket from wherever it's beginning. Excellent job. Okay, so we're going to move on to step 2 now. Thank you, Alexi. All right, now, Alexi mentioned air resistance. So I want to talk to you guys about different shapes that are involved in major parts of a rocket. Let me grab this yellow one. It's easier for you guys to see. So if you notice, I can take this rocket and basically, if I took off these fins, I have a tube just like you guys made already, okay? But most of our rockets want to be as efficient as possible while they're traveling through the air. And to do that, we want to minimize air resistance. In other words, how much air does this object have to push into while it's traveling? So most rockets have a pointy top because the point better cuts through the air and thereby reduces or takes away most of the air resistance. So this is called the nose cone of a rocket, and it allows the rocket to better deal with air resistance. Which brings us to another important part of the rocket, and that is the fins. Okay, the fins do a lot with air resistance, but they want to use the air resistance more than the nose cone does. While the nose cone wants to totally get rid of air resistance, the fins, their purpose is for direction, the direction that the rocket flies. Okay, so these fins, if you look at, are perfectly straight up and down. Okay, and just like a boat rudder in the water, they cut through the air. And if they're straight up and down vertically, right with the nose cone, that will help the rocket fly straight through the air. Okay, so you might have noticed with the first step that we built, your rocket may not have flown so straight because it has, number one, a flat surface that's pushing into much more air than a nose cone would. And number two, no directional fins, okay? So that's what we're gonna work on this step. And so I'll show you some basics on what we can do to build fins and the nose cone. Okay. So if you take your paper and cut it into a square, okay, grab a scissor. And I have a square, and we're going to start with a very basic shape known as the triangle, okay? You guys can work on any shapes you want for the fins, but you want it for now to be something that is a little thicker than one sheet of paper. So I'm going to fold this over. I personally am going to fold it over twice, and that gives me the nice shape of a fin. Then what I'm going to do is I'm going to take these openings and I'm going to tape them shut so that they don't let any other air inside them. So you can grab your tape. It can be any type of tape.
You can catch up.
Okay. I'm going to tape off that opening seam. I have a little extra tape here. I'm just going to cut that off. And I'm going to do that second side I showed you. Okay. And now I can get to my body tube of my rocket and I can tape it on like this. So that's what I'm going to do. A good technique is to take the side that you want to go on the rocket and give it a half a strip of tape, and then this way you can try and line it up so that it's vertical with the body tube. Okay, and that gives me one side complete. And then I'm going to grab another piece of tape and do the other side of that fin. Okay, and now I have a pretty good, straight, sturdy fin. Okay, maybe you want 3 fins on your body tube. Maybe you want 4. You can have 5 if you want, as many as you want. Okay, the more fins that you add to your body tube, the more control they will have over the direction of flight of the rocket. Okay. Now I'm going to show you how I would do a nose cone. You don't have to do it this way. Again, this is your own creation. Use your imagination if you want to do something different than I'm going to show you. So basically, I'm going to take another sheet of paper, and I'm going to roll it kind of on an angle so that it turns into some sort of a cone or a funnel, I will say. Okay, so to do that, I'm going to take one side of my paper and make that very tight to the roll. Let me see if I can get this for you guys to view a little bit better. Okay, and the other side, I'm going to leave a little bit more open, okay? And it's going to turn into something that's moving all around, okay? I'm going to try again here because you might lose it there if you don't hold it perfectly still. That's better. Okay, and if you can see, I'm getting a good cone shape here. Okay, again, you might have a better technique than me. You're engineers too. So while I have that still in my hands, I'm going to tape as best I can so that it doesn't move. I'm going to move my hand up a little so I have room to tape here as well. And little side note to our technical team, there's still a student trying to get in, waiting to receive a link. Thank you. All right, so I have this pretty much taped up along the seam. Now I'm going to take my fin and my body tube, and now is time for me to decide, how am I going to get this to fit on this? Well, I'm just going to use my eye and try and do some comparison between all the different diameters of this cone compared to the diameter of my rocket tube. And I'm gonna guess that it looks like it's about like that as far as the same size. And I was pretty close, so I'm happy with that. Now I'm gonna try and fit it on, and if I like the fit, I'm gonna tape it and seal it. And I love the fit. You can see it's angling off a little bit, so let's adjust it, and that I like. So I'm gonna tape that. And then I'm gonna let you guys go. So good luck. I hope we come back in about 5 minutes and you are ready to share your great ideas. And then after that, we will go to break for your health and wellness with Mary.
I will help you. But think. Okay, all right. Okay, so what are we doing now? Sit down. All right. Well, let's see. Let's see when they come back. So, what did you have to do with this part?
I don't know.
Okay.
They told me to walk off one thing. I don't get.
Okay, all right. Let's see what they say. Did you have to? Oh, you did. Good. All right. Well, let's see what he says for the next part.
He told us to put things on it.
Okay. Okay. Don't get panicked. Let's see. Go get my glasses quickly. Over there. Get my glasses. Oh, where's the volume?
She's not talking.
He said something.
She didn't say anything.
Hey guys, this is just a little interruption in your own work time. I do hear one of our friends is having a little problem in this stage, so please talk to me and I will walk you through any issues you're having. I'm trying to find out who you are.
So it looks like we have to do this now, right? Tape this together?
Yeah.
All right, so get some.
Hello, ma'am. I can hear you talking about taping something together. Do you want to ask me anything? Okay.
I'm gonna need more.
That way they won't open like this. But do it like
That.
that.
We need a couple more because they're not working.
Now you gotta tape that one together here.
And we need to tape
You
that.
talked about how to get the pointy part?
Just to get a
Are we
cone.
up to that yet? What? You meant
Yeah,
to
we're
make a
up to
cone? Oh, okay. So like this to make a cone. You gotta start at an angle.
I'm making it open. Make it white.
All right, let's see the cone first.
Natalie, can you hear me?
Yes.
How you doing? You look like you're doing excellent. Don't worry about not getting it perfect or even correct, okay?
I needed it. And
Yeah, how did you do it just now?
I don't know.
Here, paper for the cone?
Oh, yeah.
Okay, so,
Let's go to scrap
shut
on
it
this.
so we can hear. Let's go like this.
Come on.
It's a little crooked, but you know, you did
What's
good.
this one? Yay, we did it.
Now,
Now we need the top in here.
right?
Ooh,
So you need to,
no.
you sort of need to cut it out to see where the part is. Maybe around here.
So we
So
need.
here, cut it out.
Hey, everybody. Let's all come back and see what we have together. So I'm looking around my screen. I see so many engineers hard at work. I see smiles on faces. So who wants to share with us? Oh, I see Lola again. Thank you, Lola. Is there anybody else who has not had a chance to share yet, wants to share? Okay, Lola, just give me 1 second. And okay, Lola, we're going to come back to you if you want to update us on your progress. Just make sure you hit unmute first.
Well, so I made this, but the tip is kind of wonky because it was
Okay,
kind of hard to make, but.
I like that word, wonky.
And I made 3 fins. I made 2 on the sides and 1 in the back.
That's excellent. And was there a reason that you chose the 2 sides and the back instead of a different layout?
Well, kind of, because I didn't want to put 1 in the front because I didn't want to do 4.
Okay.
So I just made a smaller one to put in the back. Because the 2, I didn't want just 2 because they weren't standing up. So I put 3 and I made 1 smaller one.
That is so cool. You could call your rocket the Wonky Wocket. So if you were to do it again, did you figure anything out while you were making that nose cone that you could try differently to improve it if you did not want it wonky?
Well, yeah, I would maybe have used something to like make the shape, like something that already had a pointy shape.
Yes, okay, that's a great idea. Another idea you could use if anybody's having a lot of trouble with that funnel cone type idea is, I'll show you. You can make it more of a polygon where you could fold it instead of having all the various angles you have to work with when you roll it. So I could literally take this piece of paper, fold it, you know, on an angle, okay, and then fold it again on that same angle several times, okay. And so I basically have this folded over like this, and once I cut it, okay, it'll look like this, and I can basically turn it into, it's a cone. It's not perfectly round, but it would work, okay? Kind of like a pyramid shape. Okay, I want to hear from another one of you guys, and I'm going to ask a young man I see with his hand up named Liam. But before you start talking, Liam, can you please unmute your, oh, you're good to go.
And you did it.
Okay, Mr. Liam, can you tell us your experience with trying to figure out a nose cone and fin?
Okay, so I did the twisting thing like on diagonal, and
Can you hold it up for the camera? Oh, that's excellent. Okay, that came out good.
but I'm still doing the fins.
Yeah, this is a little time consuming, and we are trying to get a lot done for the 5 minutes. So I'm going to try and slow up a little bit for you guys. And we're already into our wellness break. So we are going to end with you, Liam, sharing and then break into that. But let's let you finish up first. So go on.
And then with the tape, I just did a circle around and finished the tape. And where's the garbage?
Ah, that's a funny one. Liam happens to know that I'm also a school teacher, and a lot of times my students will be a little silly and say, hey, Mr. Phillips, where is the garbage? And sometimes I laugh about that because usually it's very easy to find the garbage, students. So anyway, when we come back, I'm going to leave you in a second, and you're going to go with Mary, who's going to lead you in some cool refocusing healthy exercises. So I hope you enjoy it. And when we come back, we will work on challenge number 3, and I will see you then. Enjoy, everybody. I'll see you in 10 minutes. Bye.
Hi, guys.
Hi.
Can everyone hear me? Give me a thumbs up if you can hear me. Awesome. Okay. So who here, everyone raise your hand, who here has done yoga before? Okay. So we've got a decent amount of people who've done yoga, even a little bit of yoga. So what we're going to do today to start, though, is we're just going to let you move a little bit. We're going to start with our hands. So I want everyone to bring their hands up for me for a moment. And we're going to count down from 10. And we're gonna rub our hands as fast as we can for 10 seconds. Ready, set, go. 10, 9, they're gonna start to feel hot. 8, 7, 6, 5, 4, 3, 2, 1. Now take your hands, bring them to your face and go. And we're gonna do that one more time again. We're gonna take our hands together and we're gonna put them on our head this time. So ready, let's go count down from 10 again as fast as you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Breathe on your head. Good, and then we're gonna do it one more time. And this time when you put your hands on your face, they might even feel hot to the touch because we're creating energy in our hands. So you ready? We're gonna go as fast as we can. Ready, set, go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hands to your face. Now we're going to do the 4 B's, and then we're going to start to move after that for 5 minutes. You're going to bring your hand into your heart center. So this is break. So break is the first B. The second one is brain. The third one is body. So you're going to hug your body. And the fourth one is breath or belly. So you're going to come to your belly, and we're going to take 4 breaths on each. And anytime you need to during the day, you can stop and do the 4 B's. So bring your hands into your heart center. We start with break and 4 breaths in and out your nose. I want to see deep breaths here. I can see everyone. Really take the breath in. One more. Hand to your head comes brain. Inhale and push down a little bit. Don't hurt yourself, but give your head a little push. Because sometimes when you're on the computer and you're working at school all day even, my brain gets a little tired. So keep breathing here. Good, one more. Next one is body. So you're gonna give yourself the biggest hug you can. If you can even reach your hands all the way back. Modern technology, I'm still learning with it. Okay, here we go, got it. Hold on 1 second, guys. Woo! Everyone keep hugging their bodies for a second. There we go. Okay. 3. And then from here, you're going to bring your hands to your belly. Okay? Take a nice deep inhale. 3 more. 1 more. And let it go. Okay, the next one we're gonna do is, I call this the eagle arm swim. So you're gonna bring your arms out in front of you. I wanna see arms because I can see you guys now. Ready? Bring your arms out in front of you. You're gonna crisscross your arms and you're gonna make eagle arms. Have you ever made eagle arms in yoga? And then you're gonna swim and you're gonna roll through your body and get all the way in there. Keep moving, keep moving, keep moving. It's almost like an elephant trunk. And I wanna see everyone go as wide as you can. Now stand up from your chairs when you do this. I wanna see you go really wide. Find all that movement in your body. 3 more, 2, 1, and then reach your arms up high to the sky, as high as you can. Now come onto your tippy toes. And then you're gonna switch the arms. So whatever elbow is underneath, you're gonna switch them out and you're gonna round again and you're gonna take that swim. Swim, 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 swim. And then from here, you're gonna melt all the way down to your toes. Who can touch their toes? Let me see, who can touch their toes? Everyone get down as far as you can. Let me see who can touch their toes. And now from here, reach all the way back up. Get high on your toes. 3 breaths, 2, and then all the way back down. 3, 2, and then all the way back up. 3, 2, and then from here, we're gonna take 10 jumping jacks. Show me your jumping jacks. You ready? As fast as you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now bring your hands back into your heart center. Slow down your breath. 3 breaths here. Ready? Well, everyone, can we unmute you guys? How do I unmute you guys? Let's see. Do you know how to unmute yourselves? Awesome. So what I want you to do now is we're going to bring our hands into Oh, I got it. I can hear you now. Everyone say hi so I can hear you for a second. Hi.
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 Hello.
Okay. We're going to do one more breath exercise. And I call this the Mr. Ed because it sounds like a horse. Mr. Ed was a horse from a long time ago. But I want you to take a big inhale, and then you're going to flutter through your lips like this. Mindful of your neighbors. One more time, nice big inhale. Let it flutter. And then one more. I know, it feels ridiculous and silly. But we'll finish with this. Ready? Hands into heart center. Take 3 slow inhales and exhales. And then the last thing we're going to do is finish off like we started. 10, count down from 10, and then ready, touch your face. Take an inhale. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
My hands are cold.
Your hands are cold?
They've been freezing. Like my hands are freezing.
Okay, so what you have to do now, if your hands are getting cold, guys, I want you to do that more, and then you're going to open and close your hands a couple times during the day, okay? To the point where they almost get tired, they're going to feel like you can't move them. And I know your teacher is back, so I'm going to send you guys back to your science teacher over here. I believe that's what you're working on? Science?
Yep.
On rockets.
Ooh, rockets. Oh, nice. All right, well, I'm going to let you guys go back. It was so much fun to hang out with you. Have fun, everyone. Bye, Mr. Phillips.
Bye.
Bye.
Hey, Betsy.
All right, everybody, welcome back. I hope you got to stretch out your bodies and jungle your minds and clear your thoughts, and are now ready to carry on with our awesome, fun rocket excitement. So a quick little review before we go in. We have about 40 minutes left in class, and what we covered already is so widespread when we're talking about math and science and engineering. You all used such wonderful imaginations and were creative in considering things like Newton's third law of motion, air pressure we talked about the science of shapes. We had to deal with different diameters in math and measurements of lengths, the forces. We talked about the directional tool of fins on a rocket, air resistance, the nose cone being so aerodynamic, the different shapes and functions of the rocket. We're dealing with gravity, measurement. This is all great. So in step 3, please hold your questions for a minute, and I'll get to that as soon as I show you or talk to you about what we're going to do next. So we're going to talk about engineering for the user's convenience or function. Okay, so mostly rockets not only don't get shot off into the air by people's lungs, we use all different types of powerful forces to use Newton's third law of motion to separate the rocket from Earth and beat gravity. But for our purposes, we're going to make it convenient for us steam engineers. And one thing that I noticed was a big problem was not only that we're using our own lungs and air pressure, but also that if we want the rocket to shoot up, we had to bend our neck. Okay, not very convenient. So we're talking about a vocabulary word called ergonomics. Ergonomics is the science of engineering things so that they're comfortable for users to experience. For example, a computer screen is usually about eye level for people, not on the ceiling, not on the floor, and your keyboards are usually designed to be at a nice, comfortable level for your hands, as well as the mouse. Same within a car. We have our steering wheel right in front of us, and the radio controls might be off to the side, or these days even on your screen, your wheel with a screen. So these are all things that engineers consider when we talk about ergonomics. So let's make our rockets a little bit more ergonomic for us. And for that, number one, I want to show you a cool way to change the direction of force coming out of your lungs. And if you have a straw, and we're able to get one of these when you saw the supply list, you can take, if you have a bendy straw, your job is easy. But if you don't, you can cut a straw and tape it into an angle. And we can make little rockets just the same as we did before. If I place my rocket right over here, now look, I can shoot my rocket off in a vertical direction with the force being changed from a horizontal direction. Another thing we can do, and because we're all working at different speeds, I'm going to kind of give you the fourth challenge as well right now, so we can kind of mesh between challenges 3 and 4 together, but we'll still take breaks in between to discuss and share and give you two separate work times, okay? The other one is, what if I don't even want to power the rocket with my lungs anymore? Well, if you saw on the supply list that I suggested it might be cool if you had an empty water bottle, we could pretend this is an air pressure system as well, and we don't have to use our lungs anymore. So what would you do? Well, I would turn this into some sort of a launch pad, and basically connect a tube to the water bottle I would have to, when I make my body tube, I would want to wrap it right around the nozzle of my bottle so that it's the same size, and then seal it with a good amount of tape so that no air escapes there. So after doing that, I can end up with a product like this, where I have my tube sealed to the water bottle. I used duct tape here because for this purpose it's a lot stronger than clear Scotch tape or masking tape. You don't have to though. And then again, I made a tube that's a little wider. I didn't add the nose cone for you or the fins yet. And just to remind you that we need to seal the top, I used masking tape so it's a little bit more visible. And now, instead of using our lungs, inhaling and exhaling, and doing all that work, we can use our skeletal muscles and basically pop this in. Off goes a rocket using the same concept of air pressure, but a different system to deliver it. So I'm going to let you go for 5 minutes. I will see that if anybody has their hands up, I will try and unmute you during work time so you can ask me any questions, and I'll be glad to help you out, answer them, and guide you if you need some specific instructions. But that will be one at a time, and you will also be able to listen to them ask me the questions and responses. So I'm going to start a 5-minute timer now, and first I'm going to start off by trying to help Ava, who has her hand up. So you guys can work on both the straw idea and the water bottle idea. Like I said, this would be like step 3, step 4, but we can combine it now based that we're working in different paces, and we'll still come back and share 2 times before we wrap up for the day. So starting a 5-minute timer now. You guys have great fun, and you can listen in on Ava's question. Thanks, everybody. Okay, Ava, I'm trying to help you unmute. If you can do the same. Hi.
All right. So pretty much I found that once I added the nozzle and these, I can't blow it as far because it's too heavy. How will you, because the tape and a bunch of stuff is making it too heavy.
And I need a piece of paper.
Right. I see exactly what you're saying. So, okay. It's still shot, and thank you for that graphic because it came right at our screen. So cool.
And
So,
I also need this.
We can wrap this around.
excellent. So you're a little ahead with step 3 or challenge 3, but maybe you want to go back and revisit step 2
Yeah.
because your concern now is one that everybody who engineers rockets is always concerned about: the weight of the rocket, because the heavier it is, the worse or the more force gravity is going to have pulling it down. So a couple ideas for your improvement. So basically in the engineering design process so far, you just explained to me how your evaluation went of your new product. So now you know that your evaluation is that I think it's too heavy.
Yeah.
So what is a good solution to improve on our engineering project now?
Well, it won't take me a while to make a new one, but I think if you are going to start to make another one, a better decision to do is to either use masking tape or don't put as much tape.
Very good.
Or,
So I'm giving you a hint at the same time here. Maybe you also want to use less paper, not so much on the piece that you're shooting the air through, but the rocket itself maybe could become lighter with my suggestion of less paper and your suggestion of less tape.
and also, like, you also should probably like triangle it. It goes further that way.
Very cool. Very cool.
Thank you.
You're welcome. So if anybody else would like to ask a question, if I see your hand up during this work period, I will totally notice it and call on you. We have about 2 minutes left in this mini session. I see Natalie hard at work and Lola and Alexi. Looks like he has a real rocket almost ready to shoot up into space today. And oh, I see a hand up and my screen tells me it's Sophia. I know you might have somebody else's account, so let's unmute if you can.
You have to measure from the bottom person.
It has to be.
Okay, hi, Sophia. Is it Sophia?
Yeah.
How are you today? Thank you for participating.
So I have a question.
Yeah.
Is this, so this is supposed to go in here?
Well,
My rocket?
the example that I showed you, that piece that you're holding in your right hand goes over. But there is a way to do it the way you have it, but you want it to be over the tube connected to the bottle.
Okay.
Because if you think about it, if I put my rocket over the tube, then I can still have my fin. But if it goes inside the tube, my fins won't fit, right?
Yeah.
So does that answer your question?
Yes.
So it's awesome that you ran into that problem, because one of my favorite things with engineering is running into problems, because I learn more. And I learn how to do things the right way after learning from my mistakes.
Yes.
So there's no problem, especially with this project, as rolling another piece of paper that this time is wider than the launch system tube. Okay?
Okay.
All right, awesome. See you in a couple minutes.
Figure it out.
Actually, we're all going to be coming back very soon. I'll give you guys another minute, how about? And then we'll come back and share our stage 3, we'll call it stage 3 rocket engineering. And I see some TikTok dancing going on next to Sophia. Is that what we're having here? This is good entertainment. Thank you very much, ma'am. Very cool. The one thing we definitely want to do every time we get together is keep having fun. So if we're smiling or dancing or laughing, then we're all in a great spot. All right, so we are going to wrap up that stage and come back and everybody share our work. I see Lola has her hand up again. Thank you so much, Lola. And once again, I'm going to see if somebody else wants to share. I see Alexi. Anybody that has not gone yet? Okay, I'm going to start with, oh, is that Sophia with your hand up? Let's go back to Sophia, then we'll talk with Alexi and Lola. So, Sophia, can you please unmute?
It worked.
Okay. All right, we're going to move on Sophia is, we're having an unmute issue, so I'm gonna scroll over and find my friend Alexi. Alexi, can we unmute you and go over your awesome project?
Yeah.
Hi,
So-
buddy, how's it going?
So what I've done is actually, I'm not using my lungs anymore. I've made a launch pad. As you can see, I've called it.
Oh, cool. I like the label. Very good.
I can't really launch it though. It's a problem, but
Okay, well, let's see what's going on with that problem.
I can just lower it. It doesn't really work.
Oh, interesting. Very interesting. Okay, so it's moving up the launch pad. Oh, there we go. So let me ask you a couple of questions, Alexi.
Yeah.
Your bottle, is it much more strong than a flimsy water bottle?
Yes, it is.
Yeah.
Okay, that could be one of the issues. And my other question is concerning your seal. How do you feel like the seal is as far as the tape keeping the air in around the bottle and up the tube?
Keeps it.
Jeez, this is big.
Well,
How's it gonna fit on my bedroom?
is that what happens is that discovered there was an air hole. We sellotaped it we sellotaped it again, and it still didn't really work as well. We thought it was going to be really good, but it actually didn't work out that well.
Okay, well, what do you think the problem is?
Well, what I think the problem is, well, the first thing is that, well, do you see this bit of the rocket? It's a little bit wobbly
Yes.
as well. So these two are fine, but these two are really wobbly and they're coming out of shape sometimes.
Okay, so maybe some reinforcement is needed there.
Maybe also this bottle is maybe like a little bit like stronger plastic than a normal plastic bottle.
Yes, so our strength of compressing that bottle with our hands is a little bit more limited, so we can't as easily transfer the energy from our muscles to inside that air, right?
Yeah.
So I wonder, not that we could see it on video, I wonder if your rocket would launch a lot more successfully if it was laid on the ground and you stomped on that bottle with your foot. You want to try that if it's a safe experiment there in your home?
I don't want my launch pad thing to be destroyed, so.
Okay, so why don't you leave it alone? Don't destroy your launch pad, buddy. I don't want that to happen. We'll move over to our next engineer. Who else wants to? Oh, yay! I see Natalie. Natalie, can you unmute, please? Oh, we are unmuted.
I'm already unmuted.
Yes, you are. My apologies. So let us see your rocket in the screen, please. Oh, it's so colorful. Hi, Mom. How are you today? Nice to see you.
Nice to see
Okay, Natalie, since it's your first time sharing today, you can share anything you want about what you were building today. Anything that you thought was cool to learn or problems that you were able to solve?
At first, when I put these fins on, they were wobbly and not standing.
Okay.
And then I put some tape on the other side of the fin too, and it worked.
Very cool. And so, did your rocket work okay when we did the first stage where it was just us blowing inside the tube?
No,
It did not. And what do you think your problem was?
it was maybe too big for me to blow.
Okay, so it was just too much mass for the amount of pressure you could create from your body, right? So what about this new model that you created sitting in front of us all now? Does this one work?
Not really.
Okay.
Yeah.
Here, try it
Here.
again. No, you can't push it.
Looks like it wants to move.
Yeah. Right.
Okay.
Yeah, it doesn't work right now.
It was working.
Yes, I see that it probably
Maybe you
was.
need more tape.
No, I think I need more air.
You need more air.
All right, take your time. Try setting it up again, and let's give it a whack with both hands.
More tape around it or something.
Yeah, maybe you're losing some air pressure.
No, backwards. Why do you give me a backwards feet?
Okay. Well, thank you, Natalie. I'll try and come back to you after you do that little adjustment.
Yep,
Oh,
it's
Okay.
gonna take a long time.
let me go to, I see Lola. Actually, Sophia, now you're ready. Let's unmute.
It was
Find you the
working.
tape.
We're going to mute Natalie, and let's go over to Sophia, and then Lola, I promise I'm coming to you. Okay, Sophia, please unmute.
Okay.
Excellent.
So my question, mine's not working. It's not going to go like that. It's just falling down into the
Okay.
bottle. And
So-
so like,
Can you take, oh, so your rocket is inside the tube, right?
yeah.
So what you want to do is design the rocket to go over this tube.
Oh.
Okay, so let me see if I can find, here it is. So watch this, Sophia, okay?
Okay.
So we have this, basically it's just a water bottle and a tube that I made that fit around the water bottle nozzle, right? And then two things with the tape. I made sure this was very tightly sealed so no air could get out. And then I made sure the seam in the paper here is tightly sealed as well.
Mhm.
Now, step two, the rocket itself you want to fit over the launch pad.
Oh.
And number two with the rocket itself is make sure you don't let any air escape the top with some tape.
Oh,
So
okay.
then, if you watch me, I will basically put the rocket I designed over the launch pad and voila.
Okay.
So no problem. We're going to have our fourth work session pretty much doing the same challenge. So I'm going to get with Lola real quick. She's going to share briefly, and then we'll go into another 5-minute work session for you. And when we get into that, Ava, I see your hand up, and I will get to you as well during the 5-minute work session. So I will go over to Lola. How are you? You want to unmute? I saw your hand up earlier.
Yeah.
How's it going?
Well, mine doesn't exactly work.
Okay.
But, I mean, it kind of works if I put it on the ground like this.
Okay. Kind of.
Kind of, but it's not really working that well.
Okay. That's totally understandable, Lola. And I'll talk with you guys about that briefly while we're getting into our last 5-minute work session. So I'm going to mute you and we'll talk about that right now. I'm glad you brought that up. So, everybody, biggest thing to remember when we're playing with STEAM and engineering things is nobody has made the same thing that you're trying to make right now, or at least your version of it, okay? And anytime an engineer creates something new, and this is why I love learning from mistakes, is that you're going to have problems. Nothing's ever going to work the first time. Okay? Work correctly the first time. And that goes with any products. Think of your TV, your iPhone, the real rockets that made it to Mars, okay? These things have to be tried and tried and tried again. So we're talking about using our inner grit and our perseverance and never giving up. And if we do that, then we can take all of the problems that we run into, whether our two tubes are too tightly made together and there's too much friction, or some of you might have too much space in between the tube and the rocket, letting all of the air out. Or maybe our paper is kinked or bent in the wrong way. When we're working with these rockets and so many moving parts and different shapes, we're going to have a lot of problems arise. Okay? The trick is to treat it like a puzzle and learn from our mistakes and figure out how to solve those problems. And before you know it, if you don't give up, your rocket will shoot up into the sky. So right now it's 2:46. We have about 14 minutes left in the class. Let's take another few minutes, and I'm going to let you do a couple different things at this point. Number one, work on your launch pad system. See if you can make it even better, or if it didn't work the first time, see if you can get it to work, okay? You can continue to work with the angled straw idea, or the bottle idea, or maybe you have your own way of getting the rocket to launch without using your lungs. With that said, I'm going to give you guys about 5 minutes before we share and wrap up. And while I'm giving you that time, I will answer anybody with their hand up, okay? So go ahead, I'll start a 5-minute timer, and I'm going to start with Ava because I see her hand up. Hi, Ava, please unmute and let's talk. Okay, I can hear you.
You can? You
Yes.
can? Okay. So I decided to put two of the straws together. I decided to put 2 straws together to see if it would make a difference. So this is 2 straws. And now
Okay.
1 straw. Let me just get one not bent. Okay. Now 1 straw. Do you know why 1 straw works more?
My guess is 2 different reasons, okay? When you add the second straw, you're leaving open the possibility of a problem with air leaking out where the 2 straws will meet. Okay, so that's one issue I can think of off the top of my head. The other one is you're asking now your air energy to travel twice the distance, right?
Yeah.
So think about the amount of air you have in your body, okay? It might, if I added, let's expand the idea so it makes more clear sense. What if I had 100 straws connected together? My air might not even make it to the other side, right?
Might only make it like 4.
Maybe. But either way, that tells us that we know the power and the reach is going to get less and less with the more length we have to address, right?
Just taped it, and I want to see if it works better that way. No, it doesn't.
Okay, that's cool. But now,
Straight like this.
I can tell you're considering some awesome concepts and asking some great questions. So I'm so happy that it sounds like you're having fun with this and you're you definitely have the engineering mindset with the questions and concerns you have. I'm sure if you keep at this, you're going to have an awesome rocket and great engineering experiences in the future.
Thank you.
So I'm going to give you guys another couple minutes, but in the meantime, I'm going to keep looking see if anybody has their hand up, and I see Lara. Lara, can you unmute?
Hi.
Hi, how are you today?
I'm good. How are you?
Good. Thank you so much for joining us. It's nice to meet you.
So I was doing this one and and it's just like not really working at all. And so
Okay.
I tried to check like the things that you said to see if it was like that would make it not work. But I
Okay.
don't think any of that is happening. And when I was like trying to get it to go, I could feel air coming out, so I put more tape on it, but it's still not working. So I don't know what's happening.
Oh, that sounds frustrating. Is there a way you can get your camera on the rocket a little bit better, and so that you can show us trying to crush it with your hands to make the air pressure go? Okay. So just to start off with, Lara, I can tell you, give me 1 second. I'm going to go find that rocket. It's about 6 feet away. I can tell you that it's most likely not going to work by just squeezing it with one hand, okay? Because there's space in between here, and if the air tries to come out of this bottle too slowly, it's not going to have enough immediate force to pop that rocket up in the air. So the faster I change the air volume in the bottle, the quicker it comes out and more forceful it will be on the rocket. So if you can manage to pop both sides of it with a motion like this, see how your rocket went up? Okay, you're getting there. So the idea is to give it a lot of force as quickly as possible. Okay, you're getting there. I see a lot more movement than you had originally. And what you want to work on now is, I can tell that your outer tube, the part that we're calling the rocket, is having trouble. It might be getting caught on this launch pad tube. And sometimes what I find is, yeah, I can see your launch pad tube. Sometimes it'll work a lot better with a nice, neatly rolled tube. So if my tube is like this, can you see this? Now it's making all these obstacles for my rocket to slide over, and it's causing a lot of friction. And when it comes to rockets, we don't like friction with the launch pad very much.
So
Sometimes I'm sorry, go ahead.
should I remake this too?
I was going to say, Lara, sometimes, and this could be just as fun, sometimes my engineering ideas stink and I have to start all over. And I'm fine with that, because by then I've learned enough to make my second try even better. So why don't you try with that? And we have about 7 minutes left in our workshop today, everybody. So I just want to go around and see if anybody else wants to share before we wrap up our great time today that we were able to share. So I see Ava has her hand up again, and I thank you so much, Ava. Why don't we unmute and see what you have?
So while you were telling Lara how she should do it, I didn't tape anything to here. And I just tried the force that you told her to do with the bottle.
Yeah.
And I just put it on here and...
Whoa, look at that.
Taped on.
I'm so happy that you shared that with us. I hope everybody heard that. basically to reiterate what Ava just said, she did not even use the tube attached to the bottle. She just put it right on the bottle. And what I really like about Ava's share is that in the beginning, I told you guys, remember, this is your imagination and you are going to have your own unique solution. So Ava took out the whole tube system of the launch pad, and for her unique design, it worked out well. What will you come up with unique to your design that makes your rocket work? Let's find
Thank you.
out. So,
Thanks.
we are going to sort of wrap it up and talk about our experience today, and then talk about what's going to happen moving forward with the iKids virtual workshop. So, can anybody please raise their hands and let's talk about briefly, what did we learn today? What was the most fun thing you think you learned today? Anything about rocket science that we discussed, or forces? Okay, Ava, I'm going to call on you. Thanks again. I'm going to unmute you, or you're going to unmute you.
Okay, so I learned that I was trying out earlier with this. I learned that like your breath like doesn't go that far, or like how much you push with your like mouth. And also I learned that the reason why it wasn't working is because when I blow, this is a flat surface, so the air comes back down. So
Right.
I need this straw, I need to attach a big tube on this so it could fit right in here.
Very cool.
It's just bouncing back down over there.
Right, so you're losing air down below that isn't doing the rocket's thrust any good, right?
Mm-hmm.
So you can compensate for that in the next version of your project, of your engineering. Okay, so real life scientists would notice that loss of air on the bottom, and they might put a platform on the bottom for the air to push off of instead of the air flowing right into other air.
Mm-hmm.
So thank you so much. Moving on, can I please have, it looks like Lara's going to share with us. Lara, did you have your hand up, or were you reaching up into, okay.
I was just reaching up for the tape, but I can.
Okay, no problem, no problem. I'm going to go to Natalie then, and we'll mute Lara. And Natalie, hi.
Hi.
So you're going to be our last share as far as telling us what you learned, or what was your favorite part about today?
My favorite part was making the rocket, how it looks.
I'm so happy. And I have to agree, one of my favorite parts about your project is how it looks. You used colorful construction paper, and it's very nicely designed. Your fins are nice and symmetrical, nice straight tube, and your nose cone looks great too. You did an excellent job. I love your design. So I want to thank you so much. We are going to talk about wrapping things up right now. We have a little less than 2 minutes, but it's okay if we go a minute or two over. So let's talk about moving forward together. And first of all, I want to thank you guys so much for being with us today. And I want to tell you about a contest we have every time we have a workshop. Last Friday, we made paper bridges, and we offered one free workshop to anybody, well, not anybody, one winner who takes a photo of their project, sends it into either the Spur or the Tesla Science Center. And what I want to do is provide you with the information to do so. Because last week with the bridge challenge, we only had one person send in their work. So based on today's work, if you send to either one of these email addresses, thespur.com.
It's the spur.com virtual kids or Tesla Science Center.
Right. However, parents, if you can hear me, you can find these websites and email addresses easily on the same website that you registered your child for to be a part of this workshop. Okay? And I don't want you guys, my engineer friends, don't feel like you have to send a picture of your project as it is right now, because I'm going to offer you some extra fun to better your projects. So before you send your pictures, maybe you want to persevere even more and improve your rockets. Some suggestions? Well, of course, we love the A in STEAM. So grab yourself some markers or paintbrushes or colored construction paper and make your rocket look nicer. Number 2, work on that launch pad system. You can use cardboard. You can do so many things with other arts and crafts. And you can even research maybe like the NASA space launch pad in Florida and get some ideas and really model a good looking launch pad for an air pressure powered rocket. 3, challenge number 3. If it gets nice outside, or if you have a very high ceiling in your house, keep measuring how high your rocket goes and see how much you can improve it by making it go higher and higher and higher. So feel free to go to thespur.com or teslasciencecenter.org and upload your photos of your rocket work. Now, I want to talk to you about the next time we have a chance to get together. And that's going to be this Friday in 2 days. And it's going to be the same time, same channel. We're going to meet at 1:30 to 3 p.m. And I'm going to talk to you briefly right now about the topic. We are going to be making crazy, cool, creative cars from scratch, your very own designs. So you can go on the websites, and while you go to find the registration link, you will find the whole list of supplies that you need, and then also some suggested supplies to make your life a little bit more enjoyable and more explorative with the STEAM you can play with. Briefly, I will tell you, I'm going to encourage you to do some creative craft car research when you're gathering your materials over the next 2 days. Okay, you're going to want to find things that you could use to make a car platform or a car body. There are some great suggestions on the websites in the materials list. You're also going to want to find things that are round or that can be turned round or into discs for the wheels of your cars. And then also, how do the wheels spin on your car? You're going to want to research how you might make axles. Okay, so the wheels are going to attach to axles so that your car spins. Okay, number 3, the fun, creative design part is you're also going to want to consider, what do you want your car to look like? Okay, what do you want to be on your car? Okay, is it going to be a funny, goofy looking car with odds and ends type things on it? Or are you going to have a fast, speedy car with a racing guy and a steering wheel? The design is totally up to you. But we're all going to have our very own created cars by the end of the workshop. And I really look forward to having more fun with you guys. I hope you come back and share your fun with us online. So I'm going to say goodbye now. And also thank you so much for coming to hang out with me today.